My name is Georgy, and today I'll be hosting the interview for Elixir developer position with the experience ranging from 1 to 3 years, so like a Middle Elixir developer position. And today I'll be asking questions, and I'll be asking questions to Leo. And let me introduce myself first. So as I said, my name is Georgy. I'm 24 years old, and right now I'm located in Russia, but I'm thinking about moving to some other country in the future, and I'm a senior Elixir developer. I've been working in Elixir for about 4 years already, but I have about 5 years experience totally, and my last position was in Linux Solutions company. I worked there as a contractor, and right now I'm helping a small company to build their own kind of web market application. And I'm working on my spare time at the development of optimizing Elixir compiler called Tria, and I'm hoping to release a production-ready version this year. So, Leo, what about you?
Sure. I usually go by Leo. The Russian name is Leonid, but basically I've been doing software development for the last probably 15 or 20 years, mostly web development. I started as a Java developer back in like 2000 something, and I've been doing Ruby since 2015. I'm still doing some Ruby here and there. Basically, I only started looking into Elixir last year and got some experience, some pet projects. So yeah, so I'm pretty much interested in assessing my skills against someone who is more senior.
Great. So let's talk about Elixir, but first let's talk about web development, like in a big picture. So this question is pretty classic, but I really love to ask it on my all interviews, and it sounds like this: what happens when you open up your browser and in the URL bar you write elixir-lang.org and hit enter? So give me a description of what happens. And I don't want you to go into the browser rendering details or JavaScript engine details, just like some networking and Elixir side, how it handles and so on.
Yeah, that's pretty classy. Basically, I guess the person who's asking me is interested in a couple of things. In the way the name resolution happens, meaning that the way we get the IP address to send the packets to the server, maybe the way we destructure our packet, meaning OCI model, and maybe processing on server side. So stop me if I'm going too deep in any place, right? So basically, when user enters a URL, the machine, the server the browser kind of passes that name to the name resolution server, but before it does that, it probably does the lookup locally. Depending on the OS, it will check out the local mapping between the name and the IP address if it exists, the local cache of the DNS that already stored. But long story short, there is a DNS resolution happens through whatever the branches of DNS servers, and then eventually resolves it to the IP address and destructures the URL to basically in this case probably a TCP connection, to establish TCP connection to the server, and eventually it goes through a bunch of servers, ends up on destination gateway, whatever you call it, and then goes through usually talking about like either Nginx or some kind of a web server that like handles it. It's called reverse proxy, handles it there, and then ends up on the application server, goes through like load balancing and stuff. But long story short, it ends up on the application server that, depending on the server, probably goes through well, in Elixir or in Phoenix it's called plugs, I think. It's pretty much whatever filters are or middleware and filters are in Java or middleware in Ruby. Yeah, go ahead.
Let me stop you here. Well,
Sure.
you were saying about TCP connection, and now you're saying about plugs. Well,
Right.
I think there's something missing in between, something
Right.
which goes above the TCP connection.
Right. Yeah. So TCP connection is the lowest level, not the lowest. The lowest is IP. Kind of. It depends on like where we go. Like between internet, it's IP. If you go lower, there is like
IP is enough.
even lower. Yeah, there is like even lower protocols, but like it deconstructs it to HTTP requests, meaning that in Elixir world, in plug you'll get a connection. And connection, there is like a bunch of, it's a map, I guess, between like lots of attributes of the connection. But the long story short, the most important thing is that you get the URL, that you get the path to the resource. But the plugs usually operate on a connection and a bunch of attributes along that. So what you can do in a plug, you can, it's pretty much a decision point where you can say, all right, this is the abnormal request and we're just gonna return something right away, or we're gonna attach something to the connection, like some more attributes, or let's say if you wanna marshal or deserialize JSON a certain way, you can do it there as well. So you attach a bunch of things or modify a bunch of attributes to the connection and pass it to the well, in again, I don't know what's called in Elixir, but I'm assuming that it's the same thing. There's kind of a dispatcher controller, so something that decides which control is going to hit.
It's called router.
Router, right? So exactly. And you end up on some kind of a controller where you just process it, and there's a bunch of business logic, supposedly use MVC. So then, like, you interact with models or whatever it's called in Elixir, structs, and then you end up rendering a view and pass it back through the same stack through plugs back to the requester. So that's the initial request, at least. That's my understanding.
Oh, that's great. This was deep enough, and I have some follow-up questions.
Sure.
First one is related to networking too. As you said, there is TCP, there is IP. We don't go deeper. Yeah, there are a lot of lower level protocols. There's IP, there's TCP above IP, and there's HTTP above TCP. And as far as I know, there are like several other protocols which HTTP is upgraded to. There are several versions of these protocols. Can you elaborate on this more, like which of them exist, how they differ, which of them are modern, which of them are experimental right now?
Yeah. Again, I'm not that savvy in that. From what I understand, that there is different versions of HTTP protocol, like 1, 2, and 3, basically. And it started like they differ in a way that whether the same connection can be used for different requests, the different like requests within the different URLs within the same connection. So initially HTTP 1.0, I think, only can use like one connection for one request, and then they were, I think it's called interleaving, like pretty much mixing within the same connection. HTTP 2, I think, supports it, mixing. Pretty much it's optimization thing. Like you optimize how to receive a bunch of responses within the same connection. HTTP 3, from what I understand, also uses UDP for communication, which is, I would say, less reliable, but quicker. So there is also quick protocol, but I think this is something in between HTTP 2 and HTTP 3. That's my understanding. I'm hazy there.
All right, that's good enough. And the last thing in networking is, what do you know about HTTPS, and what does it actually mean, this S in the end, and so on?
Right. So basically, well, I guess S stands for secure. it's an encrypted protocol, so then no one in between can listen, or wiretapping, what's it called, on the data that's sent in between. The way it works is that basically you have like certificates that are signed by, I don't know, secure authorities, whatever. There's the root certificate, etc., that your browser knows about. But so there's different even versions of that secure protocol, like different handshakes and stuff. But long story short is that you send a request and the server sends a response, and you establish a secure protocol between them based on asymmetric encryption. That's how I understand it. And then the communication happens. Like everything gets encrypted, and the communication happens in like secure manner on a, usually it's port 443. That's how I take it.
Yeah, that's great. That's great. I've heard all the keywords I wanted to hear. So that's a deep explanation of how it works. Yeah, and then I'd like to ask you more about the Elixir side of things. As you said, the request goes through a set of plugs which modify the request somehow, and then they go through the router, which decides which controller the request wants to go, and then router calls the module, Elixir equivalent of module, from the MVC, gets the data from it, renders it with the view, and sends it back. And there go the technical questions about this. So first of all, about plugs. What plugs do you know? What actually is a plug, like, and what is the request which plug handles? Like, is it like some kind of structure? Maybe it is a process, or what?
Yeah, good question. I don't know if I can go that deep in there. Like pretty much the plugs that I used is the one like pretty much, I think, JSON marshalling or JSON something that handles optimization for JSON marshalling. There's a separate plugin there that you can just put in your whatever pipeline, I would say, and then it would modify things for you. I guess I missed the other part of the question. Like, could you repeat that?
Yeah, absolutely. Well, as you already said, you insert the plug into the pipeline. Well, I was asking what is a plug itself. Like, you can't answer this question already, because plug is like a function, and you
yeah, it's
form
pretty
a
much a
pipeline
module and a bunch of functions that you act in the order described. So you act on something and you pass it lower down, and just that goes on until you hit the router, I guess.
Yes, exactly. So, and the last part of this question, what is the connection? Like, the connection is passed from one plug to the next plug, and when does the connection leaves this pipeline, and so
on? So the short answer, I don't know. From what I remember, connection, like I perceive connection as just a map of things, and it's passed, like you're supposed to pass it lower down the stack. And you end up actually having connection in controller, from what I understand. Like with all of the things that you added to there or removed from there, whatever, you end up having it in the business logic. That's where, like at the controller level, the top level where you can start the business logic. That's how I remember it.
All right. That's the right answer. Actually, okay. Connection is a structure. At least the structure is a map. Yeah, this the same thing, and it handles the most importantly what the keys are inside there. So what values does it store? And from what I recall, the most important things are request parameters, plug connection, the structure. It handles request parameters. They are put in the key assigns, as far as I remember. It also handles some things like some private, it can handle some private data like IP and all this stuff in another key. I can't recall the name of the key correctly. It also handles the status of the connection, because the set of plugs it's a pipeline. So when you're answering some when you hit when you respond to this connection with something, you can't respond to the connection twice, to the request twice. So it also handles like this status of the request. Was it responded or was it not? And this is useful sometimes because, well, you can parse the request in one plug, then you can respond in the next plug, and then you want to log the request and the response which you've sent, and this is really useful for this plug pipeline. And there's also one small thing I'd like to note, that the router itself is a plug too. So, and the router itself is a plug, and it's when the request ends up in the router checks if the request was responded already or not, because there are some plugs before router which plug static, which responds with static files and all this stuff. So yeah, router is a plug too. But that's you've answered really great to this question. For Middle Elixir role, this absolutely hits the sweet spot. Next question is, you mentioned MVC. Can you elaborate more on this? What is MVC and how is MVC implemented in Elixir? And yeah, basically.
I mean, basically MVC, right? It's abbreviation stands model view controller. And from what I understand, there is different versions of MVC. There's MVC1, MVC2, and like in the modern world, we're talking about MVC2 most of the time. Basically, it's a separation. It's a application pattern, development pattern called separation of concerns. So supposedly, from what I understand, you separate your model, which is your struct in the Elixir world, like a data, from controller, which is the part that controls the flow and supposedly handles the business logic invocation and flow of the business logic, from a view. A view is the way you respond to the requester, meaning that can be anything, can be HTML in the way you respond, it can be JSON, XML, whatever the form you want to, whatever the response, the form of the response you want to have. So those are three separate things. And the way it happens is that the control gets to the initial invocation gets to the controller operates with data and using models creates either set or array of models or something that can be rendered with the view to the final result. So that's my take on it. Yeah.
Great. I have only one follow-up question for this. And how, as you said, view decides in which form, in which it can be XML, it can be HTML, it can be JSON, and view decides in which form to render the content that the controller and the model returned. So how this content type negotiation happens?
Right. So I don't know details, to be honest. From what I remember in other parts is that basically you can either describe, there's many things you can do about it, or many ways this can be kind of handled. So there is, when you are sending a request, you're sending the type of the response that you want to receive, and based on that, the server knows what to render. So basically, in the headers, you can decide what you want to render, and based on that, the renderer can say, all right, so I know what to render because the requester wants that, and this is what I'm going to do. But there's also, I don't think if it's not specified, there's some something that you can do. Maybe you can even override in configs or something default you can go with, and that can be like defined in pipeline, I think, because basically if you're dealing with like API responses and you handling it HTML there, because you can define that on /API you're only doing JSON and that's about it. Yeah, I don't think I know much more details about that.
No, that's great. You basically said all the things I wanted to hear. The only thing I want to notice is that the header you were talking about is called accept-encoding, as far as I remember, and it's specified in the MIME type. Yeah, it's called MIME type. Yeah, and there are basically different MIME types. The most common one is the application JSON and text HTML, as far as I remember. Yeah. So yeah, you've already answered all of these things. I just provided the technical details.
Thank you.
And for the next question, I'd like to go back a few steps when we were talking about plug. Well, plug itself is built upon another thing called Cowboy Web Server, and this Cowboy Web Server is actually an Erlang web server. It basically solves one thing. It spawns a listener process which listens on some specified port and has a set of processes in a pool of processes which are ready to handle responses, just handle requests. So when the request hits the web server, this listener process decides which handler to send this request to, and then this handler process handles it. So yeah, that's like the process structure of it. So this question will be about what is a process? What is a process in Elixir? Because the word process actually in computer science, it means really a lot of different things. For example, OS process, operating system processes in different operating systems, even they differ really, really heavily, and Elixir processes are really different too. So what are the differences? What are the details of this process?
Right. Okay. So basically, again, from what I understand in Elixir, we're talking about Elixir process, we're talking about Erlang, or we're talking about Erlang virtual machine, and their like its way of presenting or handling what process is, because like the other way that, like, let's say Java or other languages handle that, sometimes they call it threads. Basically, it's an independent execution flow with an Elixir and an Erlang. It's also isolated memory heap, I would say. It's like basically it's something that runs in a protected, isolated scope, and other processes can communicate through sending messages to that isolated thing. Basically, this is the idea of handling multiple things working at the same time in Beam virtual machine in order to support concurrency and parallelism and this like multi-threaded environment. But in terms of operating system, it all runs within the same OS process, meaning that technically, if there's, I don't know, some big failure somewhere, but that's not supposed to happen. Like basically, the process would share the same memory among all of the threads and all of the processes in Erlang, but the Erlang virtual machine tries to guarantee that this, even if one process within Erlang virtual machine dies and happens, the other processes will not be affected by that.
Thank you. Thank you. That's a great answer. So the things I want to note that this idea of having isolated memory and communication through sending messages is called Ecto model. And this is like this name for this idea versus threads which share memory and communicate via shared memory or even sending messages, but the main difference is this memory isolation. Each process has its own isolated memory and they share absolutely nothing, except there are little exceptions, and I want to talk about these exceptions. Do you know any kinds of memory which can be shared among different processes?
I think you're hinting me on ETS, which is Erlang term storage, I think. I'm not sure what the abbreviation stands for. Is that what you're referring to?
Yes, but without going any deeper, I think we'll talk about ETS later.
Okay.
And plus, there is also one one primitive, which is shared among different processes.
Yeah, maybe you're referring to atoms. So this is something that, I don't know.
No, well, not exactly. I don't know
Okay.
if it is correct to say that atoms are shared. Yeah, there is a shared atoms table, but yeah, well, we can say that they're shared. But there's also one more important thing, which is like exploited in all different web servers and all such stuff.
I need to think about what else can be shared among multiple processes. Yeah, I don't not on top of my head.
All right, that's a tricky one. This is like some kind of optimization. Well, before talking about this, I'd like to mention that the sending message to another process, since their memory is isolated, is basically copying this message onto the heap of the another process. So sometimes it's really extremely inefficient to copy large amounts of data. When, for example, imagine you have the pipeline which serves HTTP request. HTTP request is basically, until it's parsed, it is basically a chunk of binary data. So when you're processing this, you actually don't need to copy it until it's handled by multiple processes simultaneously. So there's this kind of reference counted binary type, which is not copied. It is shared among different processes and is called and is garbage collected in its own way. And the references are counted. So when one process finds that the reference counter to this binary is now 0 after his own garbage collection, it calls some kind of internal garbage collection. Well, basically it doesn't call it, but it schedules this kind of stuff. So yeah, the correct answer to this question, well, what is shared? It's ETS tables, they're kind of shared, and large binaries, they're shared too. And we can say atoms are shared too, but well, yeah. So, all right. I'll ask a few questions about ETS and atoms later, but right now let's continue with the processes. So, as far as I know, other languages are capable of executing concurrent code too. For example, let's say about Ruby and about Python. They are capable of executing asynchronous code too, and Python does it with the library called async.io. But there is like the key difference, which is different among these implementations of this concurrency. Can you elaborate on it more?
Maybe you're referring about GIL or global interpreter lock. At least in Ruby, from what I understand, it's kind of a restriction to allow multiple things happening at the same time, meaning that if you want to execute if you want to process like multiple threads at the same time, then you either need to like make a cooperative, like meaning that like probably use rectors or something like that. I'm not sure, but basically by default you can only execute one process at a time, so that doesn't utilize in a system. Versus in Erlang is that you can use pretty much, you can run as many threads, you can execute as many threads as you have cores in your system, because you don't have this lock, because like there's many things around that, but basically there's less problems because you don't need to have, and most of the time you need to have mutex, meaning that you don't mutate the same data because you don't share the data, because shared data is immutable. And there is more low level stuff that may not be familiar with the way Erlang handles it.
Well, yeah, you've said the things I wanted to hear. Basically, that in Python and Ruby by default, in default implementations, there can only one concurrent this thread. There can be only one thread executed at one time. So there's no multiprocessing, as it's called. But on the other side, in Elixir, there is multiprocessing, and several processes can execute code at the same time. This is done because there is nothing shared about them. And it's done with scheduling, which is really interesting to go deeper into details, but maybe for the senior level interview. All right. So the things I want to talk about is ETS. What is ETS? What features does it have? And how do you use ETS? And so on.
Yeah, I don't think I had much experience. Actually, I didn't have any experience. I don't have any experience working with ETS. But from what my gut's telling me is that basically it's like something that is a key value map that you can work with in order to keep the state in a shared space. So this is useful because like if you have some kind of a processing of data and you want to parallelize that, then instead of going through one process that can handle one message at the time, you can spread it to multiple processes and store the key value things in one space, and that will be processed in parallel for you. But I don't have much more details about, like, all I know that it's part of Erlang virtual machine, and then it's already there for you. So you don't need to, it's not Redis. You don't need to install it. You don't need to handle any connection to external servers. It's all inside. I'm not sure whether, honestly, whether it's shared among nodes. My understanding that it's not. It's only within one machine. So hence there are other things that you should be aware of. That's as far as I can tell about that.
Yeah, that's correct. That's the level of understanding I think is acceptable. I like to know that ETS provides atomicity and consistency guarantees, which are important because not every kind of shared memory, even key value memory, can have its guarantees, and it provides this kind of guarantees, though there are no transactions and all this stuff. You can think about the ETS table like a database table, but inside the memory and with Erlang terms, so it's kind of embedded. And yeah, the next question is the like important security question, I think. What can you say about atoms? How can you handle them? What are the common mistakes, and how to overcome them?
Yeah, basically, atoms is I don't know how to describe it. Like if the people are familiar with Ruby, it's something like symbols. It's a string prepended by like colon sign, and it's immutable, meaning that like it's not even garbage collected, meaning that if you've created or defined an atom somewhere, let's say statically, the virtual machine is not going to remove it from memory. So if you create, you can define an atom dynamically in your code, but we need to be careful about that, because anytime you create that atom, it's going to be stored in the memory and it's not going to be garbage collected. Meaning if you create atoms from user input, the malicious user can come up with more and more and more different atoms, and then eventually you'll run out of memory. So there's like two methods from what I remember in Elixir, like two atom or two existing atom. So two existing atom will be safer, yeah, because it will look up the atoms that you have and only will create if you have one already. Otherwise, again, if you know that the data comes from trusted source, then yeah, sure, you can do it. If it comes from untrusted source, then it's probably not a good idea.
Yeah, that's great. You've hit all the sweet spots here. So unfortunately, we don't have much time. I want to talk about Ecto, but I can ask like a small, tiny question about databases, how they're held in Elixir. So what is Ecto itself, and what are the four key parts, key concepts within Ecto?
Yeah, so Ecto is, again, I don't want to go like analogous here, but basically it's an ORM, all right? So I think it's a wrong statement that's an ORM, but it's a way you handle your database relationships or database relationship with database. So the key things there's probably schema. It's the way you define your structure of the model against database. The change set is the way you operate, the way you act upon that schema. There is query, is the way you define your queries to the database. And there is repo, is pretty much the place that it's a point where you execute your query. I probably missed something, but those are like initial facts.
Those are the parts. Yeah, you've named all of them correctly. So basically that's it. So we have 2 minutes left.
Yeah, we only have a couple of minutes, but yeah, I don't know.
I think we can wrap up this. We can wrap this up. And like the last thing I wanted to note about the Ecto itself, because I didn't ask it, but it's worth noticing. The migrations. Ecto has this
migration.
The sibling library called Ecto_SQL. And there you can define migrations. They're stored in this separate table. So I didn't ask about it, but it's okay. So it's okay. You answered the previous question correctly. And about migrations, they're stored when the migrations are run, they're stored in a separate table inside the database. So they are stateful. You can't run some migrations before the previous ones were not completed, and so on. Yeah, and that's the thing I wanted to note. So let's wrap this up. You've answered the questions correctly. I'd hire you for the Middle Elixir developer role. There are a few things I'd like to point out that it is worth for you to dig inside the Cowboy, how it works, how it handles connections, because Cowboy is something I like to Phoenix. It is worth to know how the contexts are implemented in Elixir, because Elixir actually has no model because it's not object-oriented language, but it has this idea of the context. You can generate the context in Phoenix and so on. So yeah, thank you very much.
Thank you, Georgy. It was a pleasure to talk to you. Hopefully we'll do it again, maybe in some time.
Yeah, that's great. Thank you very much. Have a nice day.
All right.
Bye-bye.
Bye.